today's class. Today we will learn about what are the services provided by operating system to user and what are the functions performed by operating system, and we will study the journey of operating system, like how it evolved from its initial stage to current stage of operating system. So now let us study what are the services provided by operating system to the user. See, when the user is running a program in the system, means the operating system in the background, it will provide some user friendly environment for the creation of the program, making it ready for the execution, and it will initiate execution, then it completes the execution. So operating system, it provides certain services to the user. Along with that, it does certain functions by itself. So the main functions of operating system are process management, memory management. So in memory management, we have main memory and secondary memory. So main memory management, secondary storage management, file management, I/O system management. That is input-output system management. So now let us study the first function of operating system, which is process management. Now what is meant by process? Is there any difference between process and program? The definition for process is a program under execution is nothing but a process. A process does nothing unless the instructions in the program are executed. So when a program is made ready for execution, it is called as a process. A time-shared user program like compiler is an example for process, and when you are running a word processor program, that is a word processing program, then it is also a process. Another example for process is, suppose you are sending some task output to a printer, then it is also a process. So a process during execution, it needs certain resources of the system. As I already said, resources available in the system are CPU time, memory space, and I/O devices. I/O devices are nothing but input-output devices. So these resources have to be allocated for each process to complete its task. Now the question is, when these resources are allocated to the process, will it be allocated during creation of the process, or will it be allocated during the queue when it is waiting for the execution, or will these resources be allocated to the process when the process is running? So these are the questions we get when the question of allocation of resource to process comes. So here the resources to the process are allocated either during the creation of the process or when it enters the system, when it is ready for the execution, or when it is executing or running. The operating system is responsible for following activities of process management. So now what are the activities that is performed by operating system during process management? What are they? First one, during creation of the process, the operating system has to do certain functions. Then during deletion of the process. So here the process means, again we have two types. Either it may be user process or system process. So during creation and deletion of both system and user process, the operating system will do certain functions. Again, say the execution of one process is going on. It will be waiting for some other resource. So during execution, the CPU will be allocated to the process. It will be doing certain instruction execution, but after some instruction, it may need some other I/O device. So there the suspension of execution of process occurs. So that is the job of operating system. So once it suspends the execution of process, then it should resume back the execution. So during that time, again the operating system will do certain functions. Then during process synchronization, it has to provide certain mechanism. During process communication also, the operating system will provide certain mechanism. Next thing is we have deadlock. So what is meant by deadlock? We will have certain processes, certain resources in the system, but a process will be holding one resource and waiting for another resource which is held by some other resource. That situation is said to be deadlock in the system. So this deadlock should be recovered or it should be cured by some mechanism. So these mechanisms will be provided by the operating system. The next function performed by the operating system related to the user program is main memory management. So we have main memory which has read-only memory and random access memory. All user programs will be stored in random access memory, and the main memory is the central to the operation of modern computer system. So what is main memory? Main memory consists of an array of contiguous memory locations where each location will be addressed in terms of words or in terms of bytes, ranging from a size of hundreds of thousands of bytes. So during execution of a program, the program is made to store in the main memory. So only then the execution starts. So the execution cycle involves fetching the instruction and storing it in the memory, then executing it. During execution of instruction, some data has to be read from the memory, and after computing, like we want to add two numbers which are stored in variables A and B. Then we have to fetch AB, and then we have to perform addition operation, and the result has to be stored back in memory, say in variable C. So here we have to read the data from A and B, then we have to write the result back to memory. So it involves data fetch cycle. The main memory is generally the large storage that the CPU is able to address and access it directly. For example, say the data is in some other disk, that is secondary storage device. So during instruction, it has to fetch the data from the secondary storage device, for which the CPU has to initiate certain calls. Then after fetching, the instruction execution will start, and during execution, the instruction must be present in the main memory of the computer. Related to memory management, the functions performed by operating system are keeping track of which part of memory are currently in use and by which user. So it has to keep an account of what are the memory locations which are engaged by whom, and it has to decide which processes are to be loaded to the memory when some space is available. Meaning, suppose some memory location is free, which is freed by the execution of previous process. Then this free memory space has to be allocated to some other process. So it has to decide to which process it should be allocated by knowing the size of the locations available and the user process size. So related to memory management, the main task or the main job of operating system is to allocate the free memory locations to the required resources and to deallocate them and make it an account of how many locations are free so that it can reallocate it to some other process. The next function performed by operating system is file management. So in file management, it is the most important component of operating system where the computer can store information in several other physical storage devices other than the main memory. So what are the other available physical storage devices are magnetic tape, magnetic disk and optical disk. So nowadays the students are unaware of these magnetic tape and magnetic disk. They are well versed with optical disk. Your CD, DVD, they are called optical disk. And also you are well versed with flash memory, that is pen drive. Each medium is controlled by a device such as disk drive. So to control disk, we have disk drive. To control magnetic tape, we have tape drive. So they have certain unique characteristics. Now what are the characteristics of these drives? They include the access speed, that is the speed of the device to access the information from the storage. Then the capacity of the device, data transfer rate and accessing methods. So they are the characteristics of the disk drive or the tape drive. Now what are the types of accessing methods? We have sequential accessing method and random access method. So example for sequential and random access method is, say initially you were recording audio and playing in the tape recorder. There, if you want to listen to the fifth song, what you were doing? You were forwarding the previous 4 songs and you are reaching the 5th song. That type of accessing is called sequential access. Random access is directly going to the 5th song and listening to it is the random access method. Sequential access method is available in magnetic tape, whereas in magnetic disk, optical disk, we have random accessing method. For convenient use of computer system, the operating system provides a uniform logical view of information storage. So each storage device has some physical properties. The operating system, it will abstract these physical properties to define the logical storage unit of file. So now what is a file? A file is a collection of related information defined by its creator. The creator is nothing but the user. The operating system is responsible for the following activities of file management. So what are the activities performed during file management? Creation of file, deletion of file. That is, if you want to run a file, first you have to create it. Once the work is over, you have to delete the file. So creating a file, deleting a file, then these files are grouped under one directory. So it has to create a directory, and once the work is over, it has to remove the directory. So creating and deleting of directories is the work of file management activity. To manipulate files and directories, the operating system has to provide certain primitives. Then it has to map files to the secondary storage devices. Suppose you have certain files, very important files. So if it is erased in the system, what will happen to the contents? So to retain the file contents, you will be backing up these files in some other media, and they are non-volatile media. Now what is meant by volatile media and non-volatile media? Volatile means When the power goes off, the contents will be erased. Non-volatile means even when the power is off, the contents will be retained. They are stored permanently. The next function performed by the operating system is related to input-output system management. So here one of the purpose of operating system is to hide the peculiarities or the certain individual characteristics of hardware devices from the user. For example, say in Unix operating system, the peculiarities of I/O devices, that is input devices, they are hidden from the bulk of the operating system itself by the input-output subsystem. So what is this input-output subsystem? What it contains? So input-output system contains the memory management component. It includes buffering, caching and spooling. So first let us study what is buffering. So buffer is nothing but a small space where few data or few frequently used instructions are stored. So once the buffer is full, it is drained out at a time. Next method is caching. So you know cache memory, it is the fastest memory which will be residing in the CPU. So what it contains? It will contain the frequently used instructions. Next method is spooling. Spooling is an acronym for the expansion, simultaneous, peripheral, operation, online. What it means, spooling? So here certain data are the instructions which are not required during execution. They are stored in secondary storage device, and when it is required on demand, it will be taken back to main memory. Next about device driver. So the device drivers, they interface with the specific hardware devices. So when we say disk drive means it will be interacting with the disk. Tape drive means it will be interacting with the magnetic tape. So only the device drivers, they will be knowing the peculiarities of that particular specific device to which it has been assigned. Now let us study secondary storage management. So when this secondary storage comes into picture, see, the main purpose of computer system is to execute user programs. The user will be writing large programs which occupies large space in the memory. Since the user program will be very large compared to the size of the main memory, the user program is made to reside in the secondary storage, and only during execution time they are fetched into the main memory along with data. Since the user program and data are stored in main memory during execution, and main memory is a volatile memory, meaning our programs will be stored in random access memory, which is a volatile memory. So the system will provide secondary storage devices to back up the main memory. In our modern computers, we have hard disk drives, that is, which are labeled as D drive, E drive, F drive. They are the hard disk drives which will store our data and program permanently. So the user will be using the secondary storage devices frequently, but they must be used efficiently, and this efficiency is provided by the operating system, and it provides the activities like free space management, storage allocation, disk scheduling. What is meant by free space management? Meaning, in the secondary storage device, certain programs will be stored and certain locations will be free. So it keeps track of all those free spaces, and if the user wants to store another program, it will allocate these spaces to the user program. So it will keep track of the storage allocation also, meaning to which program how many space are allocated. And for that it will have certain algorithm. They are called disk scheduling algorithm. Now coming to the distributed operating system. What is distributed operating system? Individual systems, they are interconnected, and one system is made as server and others are made as clients. So in this network there will be sharing, the systems will be sharing the memory and also peripheral devices and the CPU type. Each processor here in this distributed operating system will have its own local memory and local clock. But the processors together, they will communicate with each other through various communication ways. In the network, we will have several processors. They will communicate with each other, and it is inter-processor communication, which are configured in different ways. The communication network design, it must consider the routing of the message in the network and the connection between the processors. So in distributed operating system, when we have several processors and several users, we have the operating system should provide protection or security to the users and as well as to the programs. Here multi-users will have multi-programs. So in the environment, multiple programs will be executing, and the executing program said to be a process. So multiple processes will be running in the environment. They have to be protected from other process. Each process should be provided with protection and security. For this purpose, several mechanisms are available to ensure that the files, memory segments, CPU and other resources available in the system, they are operated one by only those processes which are authorized by the operating system. Till now, we studied about the functions which are provided by the operating system to the user program. Now, we will study what are the services provided by the operating system. So, operating system, it provides a convenient environment for the user to execute his program. The services provided by the operating system to the user are the first one, program execution. Okay, so during program execution, the operating system, first what it will do is, it will load the program to main memory, then it will prepare it to run it in the system. So the program after execution, either it may terminate normally. Normal termination means you will give the input, it will give the output properly. That is normal termination. Or it may stop abnormally. So when it will stop abnormally, if there is some error in the program, then you will not get the required output and it is said to be abnormal execution. The next service provided by operating system is input-output operation. Say a program is running in the system. During execution, it needs certain inputs to be read into the program, and it will produce certain outputs which should be produced through certain output devices. Example, it may take the input from the keyboard, or it may give the output to the printer. So a printer will become output device, keyboard will become input device. So these input output operations, they will involve a file. So the program may read data from the file, or it may write data to the file. Like this, it may involve the I/O devices, for example, the card reader, barcode reader, or optical character reader (OCR). They may be accessed for the input to the program. Now coming to the service, file system manipulation. See, as the name itself indicates, here the operating system will perform some services related to files. So during the execution of the program, some files may be created. So it is the job of the operating system to create the file, and then some files may be deleted. Again, the operating system will do this service. So here the deletion of file and as well as the creation of file will be done by its name. So here by file name, the operating system will do all these things by knowing the file name. And also, once the file is created, the operations performed on it are reading the contents of the file, or writing the contents to the file, or updating the file. Therefore, the operating system must maintain each and every file properly by storing its attributes like file ID, file name, its size, and so on. In network operating system or in distributed operating system, where the processors will communicate with each other, in this the operating system has to provide the service called communication. So in some way the processors, they have to communicate in the network, that is through packets. So the packets are sent between the processors for communication. The packet may contain the data and also the sender address and destination address. Say your program is running in the system. Not all the programs will give the correct output. The reason is there may be some mistake in the instruction, or there may be some other programs which are trying to enter into this program, which are trying to access the instructions in the program. So several errors will occur. These errors, we call them as execution time errors or compilation time errors. So the service provided by the operating system is, it has to take appropriate action by detecting the proper errors. The types of errors may be arithmetic overflow, or access to illegal memory location, or taking too large CPU time. The next service provided by operating system is resource allocation. As I said, operating system is also called resource allocator, meaning this is the main and the important service provided by the operating system, since many users will be using the same system and they will be logging into the system at the same time. So at a particular time in the system, many processes will be available and many resources will be available on one side. So it is the task of the operating system to allocate a particular resource to a particular process. So for the distribution of resources among various processes, the operating system will do by running the CPU scheduling algorithms and process scheduling algorithms. The operating system will keep track of the how many users are using how much of resource available in the system, and this service is said to be accounting. So it is nothing but making an inventory of the system, like what are the resources available and how many users used it for how long. So that account will be kept aside. Then the main thing is giving protection or the security for both hardware as well as for the software. So the operating system should take care of the software and the hardware by checking is there any virus or malware entering into the system. It should check it and it should remove it from the system. So for that we have antivirus and the firewalls. Students, with this we have come to the end of this session. So hope that all of you now understood what are the functions and the services provided by the operating system. Thank you.